Hi everyone, I'm still continuing with the Gauteng June Common Test, which was written in 2024. I do want to tell you guys that this question paper was interesting. How do I imagine for Numpal? Yeah. Okay. Now I want us to focus on the trigonometry part of it, né? That means I'll do question 5, 6, and 7. Here I just need to simplify, guys. Whenever I simplify here, before the addition sign, I have two terms, so I'll just open two brackets, plus, and then I'll have the numerator and the denominator. Okay, the first thing I need to do is to reduce angles. I don't want to have 90 plus, 360 minus, or negative angles all together. I just want to work with the trig ratio and the positive value of x as an angle. So in this case, to reduce tan of negative x is in the fourth quadrant, and tan is negative there, so I'll just write negative tan x. Let me try to write neatly. Negative tan x, and then whenever I see 90 plus or 90 minus, I must change to the co-ratio. But before I do that, I need to check whether this sign 90 plus is positive or negative, and then I'll just change to the co-ratio. 90 plus is on the second quadrant and sign is positive, so I'll just change to a positive cos. All together, and then I have sine 2 theta, which can be written as 2 sine x cos x, right? And then the denominator, I'll just write 2 cos 360 plus is at the first quadrant and everything is positive there, so I'll simply have cos x, right? And then for tan, now I need to change everything to sine and cos, right? Because the angles are already reduced, changing to sine and cos. Tan can be written as sine x over cos x multiplied by cos x, plus the cos can go with the cos here, and then the 2's can cancel one another. I'll be left with the plus sine x, and then this will go with this. Remember that this thing was negative there, it's a negative tan, so this simply means I'll have a negative sine x plus sine x, and then I'll get 0. So whenever I simplify that thing, the answer is 0. I would get, and I believe that the examiner will mark me like this. For writing negative tan, I'll have a mark. For writing cos x, I'll have another mark. For writing cos x here, it's another mark. Changing the identity for sine is another mark. So the first step has 4 marks already, guys. Out together, and then changing tan into sine over cos is 1 mark, and then the final answer is another mark. Out together. So please, guys, trigonometry, it will just give you 3 marks. The final answer is 0, right? So whenever I simplify this, I'll get a 0. Okay. Given sine 27 degrees is equal to P, here I just need to have my right angle triangle. Just need to have my right angle triangle here, whereby I have 27 there, I have 27 degrees there, and then I have 63 here. .27 degrees and 63. Okay, and also I know that the sine of 27, sine is always opposite over hypotenuse. That means this is P and I have 1 here. According to the Pythagoras theorem, the value of x will be 1 minus P squared, right? So for me to calculate cos 27, I just need to say the square root of 1 minus P squared. Right, together. And sine 63 is the same as cos squared 27. Sine and cos are cofunctions of each other, and if the angles between them they add up to 90, then they are equal. So whenever I see sine of an angle, I can just write cos of an angle, but the sum of the angles must be equal to 90. All together. So here I'll have 1 minus P squared, but since the cos is squared, I need to square everything there, and then my answer will be 1 minus P squared. All together. Okay, I can see that 13.5 is half of 27, so it simply means here I'm dealing with half angle identities, right? Half angle identities, guys, are always derived from the double angle identities. If I have cos theta together, cos 2 theta, I can have cos squared half of 2 theta, which is theta minus 1. Together. Half angles are always derived from the double angle for cos, right? I can take the 1 to the other side. I'll have cos 2 theta plus 1 is equal to, I can also divide by 2 both sides, and then I'll have cos squared theta together. But I don't want to have cos squared theta, I want to have cos theta. That means I must take the square root both sides. So therefore the cos of theta is equal to the square root of cos 2 theta plus 1 over 2. Are we together? So in this case, I'll simply say cos 13.5 degrees is equal to the cos of 27 theta plus 1 over 2. What is the cos of 27 theta? That's 1 minus P squared plus 1 all over 2. So here I just need to say this thing is equal to the square root of 1 minus P squared plus 1 all over 2. This will give me the half angle for cos. Okay, and then now I'm given cos of x plus sine x it's equal to k. I must express the following in terms of k. Okay, there I have a compound angle for cos, which I can expand. Okay, I have cos x multiplied by cos 45 plus sine x multiplied by sine 45 degrees. Cos 45 will give me root 2 over 2. Then I'll still have cos x. Sine 45 will also give me root 2 over 2. Still have sine x. I can take out a common factor, which is the square root of root 2 over 2. I'll be left with cos x plus sine x, and I was told that cos x plus sine x can be written as k. So it simply means I'll have root 2 over 2 multiplied by k altogether. So here I'll just say root 2 over 2 multiplied by k. Okay, 5.4 I'm supposed to prove the identity. 5.4 I'm supposed to prove the identity. Okay, on my left hand side I have cos 2 theta plus 1 over sine theta plus tan theta. Okay, I can change the double angle for cos. Since I have a positive 1 added next to cos 2 theta, I can use the double angle which has a negative 1. So I'll say 2 cos theta minus 1, then I'll say plus 1 all over sine theta plus tan can be written as sine theta over cos theta, right? And then the ones will subtract one another. Ooh, I made a mistake here, guys. This guy is cos sine 2 theta, and sine 2 theta cannot be written as just sine theta. It will be 2 sine theta cos theta. Okay, let's continue. There at the top I'll be left with 2 cos squared theta because the ones will subtract one another, all over 2 sine theta cos theta plus sine theta over cos theta, right? And then the 2 will cancel the 2, the cos will cancel one of the cos's there, and then I will be left with cos theta over sine theta plus sine theta over cos theta. Can multiply by LCD. Simply have cos squared theta plus sine squared theta. This thing is equal to 1 according to the square angle identities over sine theta cos theta. Therefore now I can conclude that the left hand side is equal to the right hand side altogether. So that's how you prove identities. Now firstly you need to check, or firstly you need to reduce angles. Here angles were already reduced, and then on the first step I was supposed to check whether I have two things which I can change into one. There were no square identities there, so I just moved on. I changed everything into sine and cos. However, I expanded the double angles for both cos and sine together, and then I simplified until until each fraction was simplified, and then I added the fractions, and then cos squared plus sine squared is equal to 1, and then I've proven my identity there. Okay. Now I'm supposed to determine the general solution. Let me erase first. The general solution. Okay, the general solution. I have 4 sine squared theta equal to sine 2 theta together. Whenever I see 90 minus, I must change to the co-ratio, and 90 minus is at the first quadrant, so everything is positive there. I'll just write sine 2 theta. Then I'll have 4 sine squared theta is equal to 2 sine theta cos theta. Can bring the 2 sine theta cos theta to the other side. I'll have 4 sine squared theta minus 2 sine theta cos theta is 0. I can take out a common factor of 2 sine theta, and then I'll have 2 sine theta as well, but minus cos theta. Then I have two things multiplied, the answer is 0. It simply means that 2 sine theta is 0, or 2 sine theta minus cos theta is 0. This thing simply means that, let me write these ones in black. My reference angle is 0 degrees. Therefore, theta is equal to 0 plus k 360, where k is an element of integers, or theta is 180 minus 0 plus k 360, where k is an element of integers. Okay, and then on the other side, I must work with one trig ratio, right? So I'll simply have 2. Then when I divide everything by cos, I'll have 2 tan theta is equal to 1. Then tan theta is 1 over 2. My reference angle is tan inverse 1 over 2. I'll get, let me go fetch the calculator. Tan inverse 1 over 2 is equal to 26.57. Okay, I have 26.57 degrees. So therefore, theta is 26.57 degrees plus k plus k 180 degrees, where k is an element of integers. So that's how we would have gone with question 5, guys. Okay, and then now let's go to question 6. Question 6 is the graphs, ne? Okay. I'm given a diagram below of which they've drawn the graph of f and g, ne? In the interval of negative 180 and 180. Okay, I'm told that the maximum value of f is 5 when x is 90 degrees. Okay, and the maximum value of g is 0. No, it can't be 0. Oh, I'm told that whenever the graph of x is at maximum, the graph of g intercepts the x-axis. Okay, now I'm supposed to find the value of a and b. A is the amplitude of f. I can say that the maximum value of f is 5 and the minimum value is negative 5. It simply means that a is 5. Then now they want me to find the value of b. The maximum value, if it happens at 90 degrees, the minimum at negative 90 degrees. And I can see that my half of a cycle still happens at 180. So it simply means b is 1. They haven't done anything to tamper with the abscissors or the x values. Okay, the graph of g is shifted 30 units to the right. Okay, and 2 units vertically downwards to form the graph of h. So basically they say that for us to get h, we must say g of x minus 30 degrees minus 2. 30 units to the right simply means you need to subtract 30 from x, and then vertically downwards you need to subtract 2. So this thing simply means that h of x is equal to h of x is equal to 4 cos x minus 30 degrees minus 2. Okay, here I'm told to calculate the minimum value of this expression g over 8 over g of x in that interval. Okay, if g is at the denominator, for me to find the maximum value of 8 over g of x, it's simply the minimum value rather, it simply means I need to find the maximum value of g. Why? Because you minimize in maths you minimize a number by maximizing its denominator. The more the denominator of a number gets bigger, that's when the number gets smaller. All together. So for me to find the minimum value, all I need to do is to take 8 and divide it with the maximum value. The maximum value for g is 4, and then I'll get what 2. So the minimum value is equal to 2 here. If a is equal to, if the coordinates of a are that, determine the coordinates of b. A and b, they show the same thing but in different periods and interval. So all I need to do is to just add 180 from the negative x value. Just say 180 minus 141.34. Then I'll get a positive 338.66. B, coordinates of b are and the y value to be just positive 3.12. So these are the coordinates of b. For what values of k will f of x have no real solution? K just represents a horizontal line, guys. For what values of k will f of x have no real solution? If k is above the maximum value, or if k is below the maximum value, we can see that the two horizontal lines do not touch or cut. So k has to be less than a negative 5, or k must be greater than 5. Okay, now I'm asked that use the graphs to determine the values of x in the interval for which the graph of f is above the graph of g. Okay, the graph of f is the sine graph. Oh, excuse me, guys. The sign there is less than. They want me to write the values of x by the graph of f is below the graph of g, right? So all I need to do is to just indicate the space whereby f of x is below the graph of g, right? So that thing happens there in that region. So whenever x is between a negative 141.34 degrees and x is between 38.66 degrees, I will have that situation whereby the graph of x is below the one of g, right? And then now they want me to indicate where the gradient of f multiplied by g will have the same sign, right? Okay, let me indicate the gradient of f by using the red ink. Whenever my graph is going down, it simply means that my gradient is negative. And when I'm at the turning point, my gradient is 0. But whenever my graph is going up, my gradient will be positive. Alright, together. Then it will be 0 turning point. When it starts to go down, simply means my gradient is negative. F prime just represents the gradient of a graph, né? And then the y values of g. If your graph is below the x-axis, the y value is negative. If your graph is at the x-axis, y is 0 there, right? And then when the graph is above the x-axis, y value is negative. Y value is negative. And then it becomes 0, then it's negative again. Okay, so in this case, I want the values of x whereby the gradient and the y value of the other function have the same sign together. So if the gradient of f is negative, I want my value of y for g to be negative as well. Are we together? So they must have this. They must have the same signs. Okay, but as you can see here, from 90 going to the left. Are we together? At 90, my y is 0 and my gradient for f of x is 0, and going to the left, they are both negative. Are we together? So here it doesn't apply. Let's see when we are at x is equal to 0 in the y-axis. Between the y-axis and y is equal to 90, both of them are positive. Okay, and then when x is 90, when x is between 90 and y-axis, they are both positive, and then here they are both negative. So here we can just say x is an element of negative 180 degrees and positive 180 degrees, because these two things keep on having the same sign for this entire interval. All together, this is not a curly bracket, it is a square bracket as well. Okay, now let's do question 7. I'm told that in the diagram below, TQR represents 3 points in a horizontal plane. On a sports field, PQ represents a vertical flag. Okay, the angle of elevation to the top of the pole from R is equal to theta, and T is also equal to theta. TQ and TR are both equal to y. QR is equal to x. Okay, and then that angle is alpha. Okay, express theta in terms of a and show that sine theta is equal to 2a. If these two are the same, that angle is a, that means this angle is also a, right? Simply means that the angles of that triangle, I can just say theta plus a, and another a will give me 180. The sum of angles of a triangle is always 180, né? So simply means theta is equal to 180 minus 2a. If I can introduce sine both sides, I can simply say sine theta is equal to the sine of, let me do this just to show that I'm introducing sine. I'll write it in black. Sine theta okay, and I still have my angle. So just to show that I've introduced sine, I wrote it in black, né? So sine theta, 180 minus is at the second quadrant. Sine is positive, so sine theta is equal to 2 sine A. I've proven that, né? And I'm told to hence prove that in triangle PQR, the length of PR is equal to that. Okay, I can see that I can simply say that in that small triangle, that's one, in triangle PQR, the cos of theta is equal to x over PR. Are we together? According to the trig ratios, because I have a right angle triangle, right? Cos is always adjacent over hypotenuse. Therefore, PR is equal to x over cos theta. Are we together? But I need to represent x as what is represented there. Are we together? How can I do so? If I go to triangle, if I go to this triangle, right, that angle there is alpha as well, no? I can use the cosine rule to find the value of x, right? How can I do that? I can simply say QR squared is equal to PT squared plus TR squared minus 2 times PT and TR multiplied by the cos of angle T, right? Please remember that angle QR is equal to x. QR is equal to x squared, and then that's y squared plus y squared minus 2 times y and y, and this is the cos of 180 minus 2a. Alright, so we'll have x squared is equal to 2y squared minus 2y squared and the cos of 2a. 180 minus is at the second quadrant and cos there is negative, so that negative cos will affect this guy to be a plus. Alright, together. So this simply means that x squared is equal to, I can take out a common factor of y squared there. I'll be left with 2 plus 2 cos 2a, not theta. Okay, cos 2a is a common, is a compound, is a double angle, right? Which can be expanded as 2 multiplied by 2 cos squared a minus 1. Still have x squared, the y squared is there, 2 plus 4 cos squared a minus 2. The 2's will subtract one another, will have 4 cos squared a. Then I can take the square root both sides. Then x will be equal to y. The square root of 4 will be 2. And then I'll have cos a, which can be written as 2y cos a. So whenever I see x there, I must put this thing out together. So I'll simply say PR is equal to 2y cos a. This thing is all over cos theta. Out together. Now I've proven that PR can be written as this. For 4 marks, the y. Okay, if A is 49, they want us to calculate the area of triangle TQR. Okay, the area of triangle TQR, we can find it by just saying it's 1/2 multiplied by TQ, which is Y, and TR, which is also Y, cos of the cos of, not cos of, man, multiplied by the sine of 180 minus 2a. So this is 1/2 y squared multiplied by sine 2a. Y is 15, and then I have sine a is 49. So I'll just use this to find my area. Let me punch my precious calculator. I have 1/12/2 multiplied by 15 squared multiplied by sine 2 times 49, which will give me 98. Is it 98? No. Okay, and I'll get 111.41. My area is 111.41 square meters. That's the area of my triangle. So guys, this is how you could have tackled trigonometry. How I could have tackled trigonometry. Please stay tuned and wait for more, guys. Thank you.